Hey guys, I'm Verlin and welcome to episode 3 of making an audio recorder inside of Godot. This is part of my From Zero to Publishing series, and so far we have made the UI, planned the project, created a GitHub repo and such. But talking about the GitHub repo, we have not really done anything with this. As a version control system, we should utilize this more. So for handling Git related stuff, I use a program called LazyGit. There are tons of ways that you can use Git. You can use it from the command line. I won't do that. I will use this UI. So first of all, let's make some commits. So we select all our icons, we create a commit, and we just add icons. That's basically the commit summary. We add this, we push this. I won't go too much into Git. It's something you should really take the time to learn properly at some point and find a tool that fits you. But once we have committed that, we can see we have 2 commits. Now our folder of icons exists. Next up, we add our Godot project, project.godot, add Godot project, voila. And then we have our, well, this is also part, so I'll quickly amend that to the add Godot project one. And then add scene. So, whoops, add scene. I really don't want to go too much into details. This is just something, if you make changes inside of your project and it's a specific part that you finished, create a commit with that so later on you can go back to it. So add interface.scene, so add, let's call this add main scene, and let's push this. A good thing about using any version control system is if you go into your commits, you can see, okay, so from here things still worked and here suddenly they don't anymore. So you can see what kind of code you changed. So I added the icon and I added this thing here. If you press here on expand file tree, we can see which files we added. There will be a red one with a minus if you deleted the file, or like things in red if you deleted certain lines of a file. Really learn Git. It's needed if you do any software development, especially if you run into bugs. It's so easy to look back and be able to fix things more easily. But yeah, programming. How do we make this software work? So if I run this now, right now, we cannot move the window. We cannot play back anything. We cannot save anything. So how can we make this work? Okay, so we need 2 scripts. I want to have the spectrum panel and the interface panel separate. So we create a new script here. We call this spectrum.gd, create. And an interface, let's create a script called interface. And voila. This is basically all we will need for making the coding work. But we have this audio stream play that we added in episode 1, I think, with a microphone. Let's call this microphone, just to keep more, well, be more organized. And then we have our buttons. So we have 4 buttons in total. We have our exit button, record, play, and save button. These all need to connect to the interface itself. So if you go into nodes, pressed, we just connect because we're already on the interface class, on exit button pressed. Same for record button, pressed, connect. Play button, pressed, connect, and save button, pressed, connect. So first of all, let's take the on exit button pressed function. It's the easiest to do. We just change this line by get 3.quit. So now if we start this up, we can exit the program. So this part is already finished. For the on the save button, what we will need to do is quite simple. So first open dialog, if file saved is pressed, run on save. And then we need another function here. So on saved, let's call it saved with a D. It will need a file path, which is a string. So we press the save button, we create a dialog, and then if the file is saved as pressed, like there's a button called save, then we run this function. So in this function first, we save the WAV file, save WAV file. And if you remember from this little like sketching out, save last path whilst using and when opened, because yeah, sometimes you want to record audio for multiple separate audio parts for a project. That way you don't have to select the same folder the entire time. So we just save paths. And we also need a path for here because we won't work on this function just yet. So that's kind of the guideline of what we need to make the save button work. Then we have the play button. Play back the audio, pause the audio. So this will be an if-else statement. We don't really need to do too much for this. What we do need for the play button is to create another audio stream player, but that's something for later, because then we will also need to change a little bit about the audio bus stuff. But yeah, anyway, so on play button pressed, that's that. And then the most important one, on record button pressed. If we were recording, then we probably need to, get the recording plus stop the recording. We need to change the icon because we want to have that as an indicator. So icon, change icon. And then maybe do some UI related stuff to change that a little bit, but I won't add that in here just yet. So else we basically start the recording and we change the icon. So that's basically the very rough guideline of how we can make this work. And again, we will need a pass to make it stop complaining about the return error. So what will we start with? Well, we are making an audio recorder, so being able to record audio would be kind of helpful, so we can start testing the save and the playback features and the audio spectrum, but this part is for the last. So first of all, we have our master audio. We will need to create a new bus, and let's create this new, let's name this new bus records. We will need to add a record effect, and that should be it. We should mute this because else, as before, if we put this one on 24 and start this, I can hear myself. So yeah, that not very pleasant if you are trying to record and you hear yourself in the background. So we mute this. But yeah, anyway, let's turn this back to 0. And first of all, we need this microphone stream player to connect to this bus. So let's choose a bus and let's put this to record. So yeah, with changing the bus, if we put this to 24, we start this. Now you won't be able to hear yourself anymore. Something you can do if you find that the record audio is too low is create in the script like a settings class, like a setting pop-up in which you can change the volume. I won't be going over to, I won't be doing that because this is supposed to be a minimum viable project. And yeah, that will just complicate the code a little bit more, and I just want to keep this minimalistic. So yeah, let's start with the record. So we need to have access to the actual like record effects. So we will need to create a couple of variables. Also, we want to change the icon, so we should probably also get the icon as a class. You can do, so the record button, you can do access as unique name. I've been running into like LSP, like language server protocol issues with it, so auto completion did not work properly. So I will just do an export button record, and it's just a texture, texture button. Okay, yeah, this should be a variable. So if we go into our interface class, now we can take our record button and drag it onto button record. Now we will also need the play button and the save button, because we also want to change like the transparency of them when there is no recording present, or like at least put them on disabled. So let's quickly add these as well. So play, which is texture button, and then we have button save, which is a normal button. And let's quickly add these as well. A little bit of future thinking. But yeah, we need the effect as well, so we can actually check if we're recording. So we just type in effect. You can call this record effect, but this is an audio effect. So let's try to find it. Audio effect record. Voila. And we will also need a var recording to get the actual audio stream WAV. If you want to change the format of how we are recording, so this is now in a WAV format, you can go into the record effect, and then in the panel here you can select 16-bit WAV, 8-bit WAV, or the IMA ADPCM. I have never used this one before. I don't really know what it does. I just choose 16-bit, it gives the best quality in my opinion. Now in effect, this is still empty. We need to set this into ready. So effect is, we need to get access to the audio server and get bus effect. Inside of here, we need a bus index and an effect index. The effect is the first one, and encoding that's 0, but bus ID comes first, and for bus ID, for the bus index, you can do audio server.get bus index, and then you can enter the name. Something you can also do, this is the second bus, so 0, 1. You can also just make this into 1, and that is what I will be doing because we won't be tampering with the audio buses anyway. So instead of having an extra function, I'll just type on directly. And with this, we got our effects. Then back into our record button pressed. If effect.is recording active, and we change this with else. Get and stop the recording. So we take our recording variable, and this is the same as effect.recording. Get recording. And we also need to stop the recording, which is also kind of easy. Effect.is recording active. No, not is recording active. Set recording active, and we set this to false. So we stop the recording, and yeah, you can kind of guess it. So to start recording, we just change this to true. And now, as a quick thing to see if you're actually recording, we can print the recording data. If this is all zeros, we did something wrong. If this actually prints things, then we know that it's working. So if we go in here and we press the record button, we need to make certain that we actually like press it and talk, because if we don't talk, it will be 0. Yeah. So yeah, let's just talk. So if I talk here and press this again, this prints information. But not having this light up red or something, you don't really know if you're recording, so we need to change the icon. I already made an icon. Again, you can get this from the GitHub repo itself. We copy the paths, and I will just put this in here. So I will create a const variable icons, which is a string. So we don't need this whole thing, this whole recording, but we have the path, and now we do a const icon recording, which is a texture 2D, and we preload path icons. I think we should probably do a percentage %s. So what this basically does is if we do this and we add another string here, so recording.svg, this will basically become res assets icons, and this will be replaced by this. But I should probably make this into a string, and this will now have a constant object of texture 2D, so it will only load once and not again. So we don't need to, we won't have any delays of a resource loading. In this case, for just an audio recorder, it won't have a very big impact, but it's also good. It's always good to follow good coding practices. Then same for not recording. And whilst we're at it, our play and pause button, they also exist. So we can just copy these. We change this to pause, and over here we change this to play, and of course over here play, pause. So again, a little bit of future planning. You shouldn't really start planning things that quickly, but if you kind of know how things will work, you're cool to it. That's still probably best practice to not do that. But yeah, we know that this prints data, so we can remove this line. We can remove this comment and change the icon. So we take our button, record, and we set the texture normal to icon. We stop the recording, so it should be icon not recording. We copy and paste this, and we just remove the not from here. So if I were to do this and use it now, it will light red if we record. But something else is bothering me. We start this up and the save button is usable, and this button is also usable, the play button. I don't want that, so I will make them disabled and have the color change. So first of all, when we start up the project, button play and button save. We set disabled to true. That way they cannot be pressed. But if you look at the play button, it still has the exact same color. So because this is a texture button, if we click on this one, the play button, it's a texture button. Even disabled, we don't have any like disabled, well, texture. I could create another texture, but something that's easier to do is I just do button play. Let's maybe put this on top. Modulate. This basically changes the visuals. So we can change this to red, any color we want. If you have an image that is white, you can easily change the color like this. But instead of changing the color, something we will do is this A, the alpha. We can make it invisible. We won't make it invisible, but what we will do is put this on like 0.7. So 1 is fully colored and 0 will be invisible. So yeah, we don't use a 255. It's basically, yeah, an integer, like a float 1 to 0. I'll put it to 0.7. We could probably create like a new const because we will need to use this value regularly. So const alpha disabled, let's just call it like this. This is a float and it's 0.7. If you have certain values that you use often, you should probably make a const, especially if they're not just 0 and 1. So alpha disabled. And if you start now, this will become kind of grayed out. It's also disabled, so we cannot click on it. This is how we want it. But when we have recording available, we need to change this. So inside of here, let's add these. So if effect is recording active, we just recorded, we have a recording able for people to use. We do A is 1, and we should probably keep this in a float, so 1.0, and this becomes false and false. I also don't want people to be able to press play and pause inside of here, so let's copy this one more time. I should have probably copied it before. And voila. So if we press our record, now there's recording available, so we can save, we can press the record. And if you press this again, these become disabled, so you cannot listen to the recording whilst you're recording. I don't know why people would want to do that. Yeah. Anyway, something about the spectrum panel as well. I kind of want to have this also kind of grayed out when we're not recording. This will make it even more obvious that you're recording at the moment. So let's create a new add export for panel spectrum. I like to use the type and then the name of it later on. Same for here, icon, and then the what it is. It makes it easier for auto completion to like find things. And this is a panel container. So instead of here, let's add the spectrum panel. Let's save again. And over here, we just add panel spectrum.modulet A. And we can use our const again, alpha disabled, inside of here as well. And inside of here, let's also turn this to 1.0. So now if we use our project, voila, and the spectrum becomes clear. I kind of want this to be clear when, yeah, I did this the opposite way, I think. So let's put this one on 1.0. So it needs to be clear when I'm recording. So yeah, that's fixed. So this is a little bit of the theming. Let's just call it like that. Recording stuff. Recording stuff. Let's just call it recording stuff. And over here, let's create a print statement, because in the code, we don't really know, like, it's kind of helpful to have print statements to know what exactly is happening in your code. So over here, recording stopped, and over here, recording started. Now, these print statements also make it more visible of what's actually happening in your code. Instead of creating comments everywhere, adding print statements can help. Do mind though that print statements can slow down coding. I don't know how, like I discovered that when I was printing a lot of stuff. It can make your project slower, so yeah, don't put print statements just everywhere. But next up, we can record audio. Now we need to probably implement some playback. So inside of our interface, we create a new audio stream player. Let's put this on the top to make it easy. And let's just call this playback. Recording playback. We will need to have access to this as well, so let's create a new export variable. I'll just call this audio playback, and it's an audio stream player. So inside of here we mix target. No, I don't think we need to do anything inside of here. Yeah, this is basically set up. So what do we need to do when recording? When recording, we probably should also set the audio, like if we play back audio, we want it to stop. So audio stuff, when we start recording, we go to our audio playback dot stop. And when we have a new recording, when we just finish recording, we can set the audio playback dot stream to our recording. This way it's automatically loaded. And I think that's everything that we need to do in the audio button. So inside of here, we can check if the audio is actually playing or not. So if audio playback dot stream paused, then we print start audio playback. And then we have an else statement, else we pause the playback. So I'm using the variable stream paused. This works and does not work at the same time. I do find it kind of annoying to deal with. So first of all, we need to change the icon again to the play or the pause icon. We need to change the stream paused variable. And that's about it. But inside, like, we can copy and paste this for here. But what we cannot do, like inside of here, if you were to just implement this, it will not work. And I'll quickly show why. So stream paused, this should become, we should set this to false. And instead of here, we set this to true. Let's also change the icon real quick. We already have our play button. So button play dot texture normal is, so we pause the playback. So we need icon pause, and inside of here, icon play. If I were to do this now, cannot call method stop on a null value. Oh yeah, we first need to, we need to go to interface, and we need to go to okay, I cannot drag it for some reason. So assign, and we just take our record playback. And now this should work. So we press this and this, and now pause audio playback. Wait, why is it pausing by default? Oh yeah, wait, no, I'm doing this wrong. I'm doing this wrong. Whoops. Yeah, we should switch these out. So these need to be here, and these need to be here. And also this should be false. I just messed up the buttons. We unpause the stream, and let's see now. So I talk a bit for the recording, and then I press play. So it still says pause. I think the default is just wrong. So our audio playback is playing, because we're not playing. Okay, and now this will work. So if you press play, start audio playback. Okay, so if it's not playing, stream pause is false. So we do need to start playing the audio, because right now, like if I do this again, nothing plays. So if we go inside of here, if playback dot play, and we just play from the beginning. So if we do this, okay, and that played back. It's a little bit silent, so let's put it a little bit bigger. I don't know how the recording will be. Maybe it's fine for the recording. I'll just do it in post, but not really, because this button stays on pause. So yeah, we have no way right now to like detect if the recording stopped or not. For that, we go into our record playback nodes, and in finished. And we just connect this. So I'll take this function and I'll put it under the play button to make things a little bit more in the same area of the code. So we need to change the icon to play again. Voila. Maybe let's have a print statement as well. So audio playback finished. And I think this should be it. Test, test, test. And it goes to 0. Okay. So that's basically those two things implemented, and now the save button. We need to create a new dialog. So var l dialog. By the way, I use a as for argument strings, argument variables. So I know it's an argument. I use the l underscore when it's a variable that's only for that specific function. So I have more of an idea which is an argument, which is a local function, and which is like a, if it does not have anything, it's a variable from the script itself. So just as a quick info point, we need a file dialog, and we, well, basically create a new one. And if a file is saved, we run on saved. So l dialog dot on file selected, on file selected dot connect. We connect this to our on saved function. And this should work, but now we have a return value discarded. Basically, connect gives us an integer to like let us know was it able to connect or not. It's not really something to worry about, so I just do a warning ignore, return value discarded. Voila, and that error is gone. Now, we don't need this one anymore, and we don't need this one anymore. And on file selected, if we look inside of this function, it returns a path. So that's why I have a file path here. If you were to like press save right now, so if I record something and press save, nothing really happens. We still need to open the dialog. So dialog.popup centered. So it will appear in the middle of the screen. If I press this now, still nothing happens. And you can also see it returns an error. It's inside tree. It's not inside tree with exclamation marks. So add child l dialog. If you run this now and test, save, it will create this. I am not a fan of the default Godot menu screen. So the first change that I will do is l dialog dot force use native dialog. We set this to true. If I were to press this now, I get my normal like system one. But there's still more issues, because right now, if I try to save it, I can save it as anything. I can save it as a PNG, which is, yeah, not the correct format. So l dialog.filters. We set this to, this needs to be a packed string array. So we set this to star.waf. Also, right now, this dialog does not know if it needs to save files, select files. So l dialog dot, let's see if I can find it. I think it's file mode. So mode open save file. So this will give us the whole interface to save files instead of like opening and open directories. Save file. Whoops. This is not 100% complete yet because we need to do the access. Whoops. Access. Because the access is the file system access scope. We need more access to save in certain folders. So for this, we just go access file system. But now if I also like try to like do this, test, save, it says save a file. So let's change the title, save, title, save recording. And if I press this now it will say save recording on top. This is also something we need to take in mind for the translating stuff, but that's something for later. Now we can normally save, well, almost save files, because we still have not done this function. So save WAV file, we basically do, we take our recording, so a recording variable, which is an audio stream WAV, and it has a function save to WAV. Instead of here, we give it a file path. But we also want to save the path. So let's create a new variable. Path last saved. Let's call it like this to make more sense. And then in our onSaved function, path last saved is a file path. There's again like the whole add return value discarded. I'll just do the warning, ignore that we did before, because save to WAV can also print if there was like something went wrong or not. We don't really do anything strange, so this should normally work. But if you look back at our design document, we want to save the last path and use it for the open location. So L dialog dot set paths. Okay, I think normally we can set the current path and we just set it to the path last saved. But we only set that if path last saved is not empty. So if path last saved is not empty, we set the current path to that path. And this should be the whole saving done. So we can quickly test this. So test. We save as tests. And normally, because of this WAV thing that we did as filters, it should automatically save as a .wav file. So if you look inside of a project, we can see we have a test WAV file. If I play this, it does something. If I quickly open it in Audacity, we can also see it has our waveforms. So now we have basically a working project. So, well, working. Something I said before, like I want to have these nice rounded corners, but I also said that we need to implement our own movements. So yeah, let's quickly do that. For making that work, we go into our title bar and we go to GUI inputs. We connect this, and something I will do with this function right away is put this more higher in the codes, and let's put this under process. So on title bar changed, first of all, I want to have this as an add event to get my naming scheme going. And instead of here, we need to check if we are dragging. Check if dragging. So if we are dragging, we need to move the window around. So we also need to save the mouse position and add mouse position. So this will make more sense later, but I think add mouse position, that's something we need to do in process. So yeah, let's get to coding this. This is a little bit more complicated. I already made a tutorial about this some time ago, about how to make a custom window in Godot. So kind of a nice watch. I won't go too much into detail in this one. A event can be a little bit of everything. So an input event, there are tons of different inputs events. So if a event is input event, we can see there are a lot. Key, MIDI, mouse. So we need mouse button. Next up, we need to do a little bit of cheating. So add event is input event mouse button. We need to do this as input event mouse button, because else auto completion won't work. Button index is if that is 1 for like our left click. Let's quickly add a pause because I quickly want to show what would happen if you don't do this as. So if I don't do this, it will say unsafe property access because it does not know that the event is actually a child called input event mouse button. So if I quickly undo this, voila, and this will be okay again because now it knows that this is an input event mouse button. If you were to put this inside of here and remove this if statement, it will try to see this as an input event mouse button. If that is not the case, it will cause an issue. So if we go in here, we had a mouse motion, so it could not detect a button index and the program basically crashed. So let's put this back. Next up, we need new variables. So we need to check if we are dragging. So is dragging, which is a bool and is by default false. Next up, we also need a mouse offset, which is a vector 2. We should set this to 0 to begin with. We don't really need to assign any value to this, but yeah, let's just do it anyway. And over here, let's also do this. Check if dragging. So that's what we'll do now. So if is dragging, So if we are not dragging and the a event is pressed, then we know that we should set is dragging to true. Because basically we already established that it is the left mouse button, so if it's pressed, we know it's this one. So we set is dragging to true, but we also need to set the mouse offset to get global mouse position. Because we need to take in mind where the mouse was to begin with, so we know what to subtract or add to the whole window. And else a event is not pressed, then we set is dragging to false. We can quickly test this if we go into process. If is dragging, print, and let's just print some numbers. So, I forgot a, oops, else if, elif. Yeah. If I run this now and I do something, I try to drag it, you will see the amount of print statements are increasing. So this works. Now we just need to create, move the window basically. This can be very easily done. We just get the window. So to add the mouse position, we first get the window and then the position. On the position, we need to add the vector. We could just to get global mouse data, get global mouse position. But, oh, whoops. Yeah, this is a vector 2i and we need a vector 2. So if I quickly cast this as a vector 2, you can basically just do this and it should normally work. Oh, whoops. Okay. This should normally work the moment that I can run this. You see, that's why we need the offset, because the window will automatically go with the corner to the mouse. We need to know the mouse offset of the thing itself, because else we get this kind of dragging, which is just not very natural to do. So we take our get global mouse position and we do minus mouse offset, and this should have fixed it. So if you drag it now, it will stay reasonably where our mouse is. There's a small delay, but I think that's probably my PC or just the way that Godot works. That's our mouse movement implemented as well. So before we go on, we have our basic functionality. The only thing that we have left to do is our spectrum. To do this, before we do this, let's quickly open our Git management tool and let's create some commits. So add bus layouts and then interface scene. Basically we add interface script. Voila. The test WAF import, let's just delete these. We don't need these. These got imported because I saved the test WAF file into the source folder. These should be gone. Okay, they're gone. And now spectrum. The spectrum is the last thing that we need to do. So let's get to it. This whole spectrum script, I took a lot of inspiration from this script, but I had to change a couple of things because, again, this code, it's not very self-explanatory. So I made my own version. Let's close this one and let's go into this function. First of all, with the spectrum, I want to not show anything, when nothing recorded, have this grayed out. But when I press the play button, I would kind of prefer to also see the audio spectrum from the audio that is playing. For this, we will need to add in our interface script, we need to add a signal. So we add a signal and we just call this is audio playing, and it has a and the variable that the argument that it gives as well is going to be a bool. So is audio playing? Let's quickly copy that, and we need to put that inside of our on play button pressed. If we start playing the audio, we need to emit this with true. Inside of here, we set this to false, and inside of our record button pressed, if we start recording, we should also set this to false. So let's put this under audio stuff, and this should also be false. So now we have this signal. What do we do with the signal? The spectrum panel needs to have access to that signal. we go into our interface script, we go into Node, and then we see our own creative function. So is audio playing? We connect this to our Spectrum panel scripts, and now we have our function here. So in here, we will be able to change the actual like bus effect. And talking about effects, before we can make this entire thing work, we need to go back into our audio and we need to add an effect. So Spectrum Analyzer. Instead of a recording, we also need a Spectrum Analyzer. This will give us access to the, well, Spectrum. So let's create a new variable, Spectrum, which is an audio, let's see if I remember this, audio effect Spectrum Analyzer instance. It's a long one. By default, we set the Spectrum to audio server. We get the get bus effect instance, and we want to have the effect from the record one, and that's 0, 1. So bus instance 1, bus index 1, and it's not the first one, it's the second one, so this also becomes 1. We copy this function, and if a value is true, this is because audio is playing. And when audio is playing, it will play on the master and not on the record. So for here, we put this on 0 and 0. And else we put this on 1.1 because we need to get the record spectrum. Because this is mute, it does not go to master. And also we could basically change this to the same function that we created, and we just set this to false, then it will automatically go to the record playback. Next up, if you look at this quick example, we can see these bars. So let's create a new variable as well. Let's make this in a const because we won't really be changing this. So let's call this bar counts. It's an integer, and let's call this, let's have 16. I will not go below 8. And like 8 is the lowest probably. 8 is the lowest because else you won't, like, for people who really want to see like the whole spectrum thing, if it's under 8, it will not really be, not very helpful. 16 is, of what I've heard, a good amount. Next up, we need a frequency maximum. I don't know where this magical number comes from. If you know, please explain it in the comments. And we also need minimum decibels. If you look into something like, OBS, you will also see it goes to -60. So I don't know enough about the whole audio stuff to properly explain this, but it works, so let's not ask questions. Next up, we need 3 arrays. So we need the maximum height of the spectrum. So the maximum height that it will go during like a specific sound, and the maximum lows, the minimum heights. And this is a packed float 64 array. Let's also create our minimum. And we also have our actual heights of how high the bars actually are. And just to keep like not having to process everything the whole time, I will also have a var bar width, which is a float, and I'll put this on 0 to begin with. If you look in the whole example, they calculate that the entire time, and that's good for when you have like a dynamically changing panel in which you want to have things displayed. But otherwise, it always creates, if I can find it. It always creates a new width. Also, I really don't like that they like call variables with just one character. Plus, it's also not statically typed, which also kind of annoys me about demo projects. But yeah, anyway, bar width. We need to calculate this. And that's kind of easy because this script is attached to the spectrum panel. So what we can do is bar width is equals to size.x to have the width of it, and we just divide by bar count, and this should work. This will give us the correct size of how big a bar should be. Also, we will have 16 bars, but right now these are basically empty. We cannot have these empty because, will not work. So for L array inside of, let's just add all of them here, max heights, min heights. This will loop through all these arrays, and we need to resize them. So L array dot resize, and we resize them to the bar count. And also we need to fill them because else it will give an error when we start, and we fill them with just 0 values. Also again, the add warning ignore because we don't use a return value. Resize can also return a value. If there was a problem with resizing the array, it's an empty array, we will never run into an issue. So we just return, like, ignore the warning. In other cases, if you like add stuff and do stuff with it all the time, you should probably check if something went wrong or not. But there is one more issue. When you start this, like, let's quickly print bar bit over here. So I just remembered that this is kind of like an issue. If I start this, this will print a 0. For some reason it's a 0, but if we let's print the size of x afterwards. If we do this, suddenly it's 15. In the beginning, it's 0. So yeah, you can't really like trust this. So I needed to do one specific thing. So instead of nodes on resize, let's make certain that we select the spectrum panel on resize, connect. Basically, this line, we should put it in this function, because after being ready, it will suddenly get the size and else it will be 0. So inside of here, we don't really need to do anything. It will get the correct size. So if we print bar width and we start it again, normally this should print the correct amount. Voila. But now the most annoying part. We need to figure out how high these bars can go, and for that we need to look at the different like hertz of a bar of a certain section. And we also need to take in mind, like, we first calculate for this, but then we need to take the previous hertz in account to go to the next one. So L previous hertz, I think that's how you pronounce it. And this is a float, and let's put this on 0 to begin with. Next up, we have 16 bars. So we should go over for I integer. So basically I use I for the index of it. So for I integer inside of bar counts, we will go over all the things. We will go over the process of calculating the hertz and the height and the maximum height, minimum height. So first we need to get the actual height. After that, decide the maximum height. Same thing for the minimum height. And this is like a part of the code if you don't really know what's going on. Like if this is like completely new for dealing with audio and such, just look at examples. That's what I did, because audio stuff, even though I made the whole like audio waveforms in Godot in my video editor recently, this is still kind of confusing. And then we need to, lastly, we need to set L previous hertz. So first of all, we need a var L hertz, which is a float, and basically we can already like satisfy the last comment. So is L8Z. So let's do this. Let's remove this pass. So get the actual height. So we need to get the hertz for that specific area. For this we need to take the index, and we do this times the frequency max, and we need to divide this by the bar count. One thing that you have with this, because we start from 0. 0 times a number always results in 0. So we should do plus 1 to this, because else this won't work. Next up, we need to get the magnitude, which is, I think, another float. And now get, let's see if it pops up. I think we need from the spectrum get, and it's kind of a long function, but get magnitude for frequency range. Luckily we have auto completion, but inside of this function we need a from hertz to hertz and mode. First of all, from hertz, that's just the L hertz that we the L previous hertz that we just calculated to the hertz that we created. So if this is our audio data that we got from the spectrum, we basically divide this into the amounts that we need for every bar. So every bar will be the same length. I guess we could kind of like create this array beforehand, so we don't need to calculate like the hertz offset the entire time. But yeah, this actually returns a vector 2, but we only need the length. And this should do it. Next up, we need to calculate the energy of that specific part. So to calculate the energy, we need this function. There's kind of a couple of things going on. So we take the minimum decibels, we do it plus the linear to dB. This is another function that I have not really any clue of how it properly works. But yeah, converts linear energy to decibels. This can be used to implement volume sliders that behave as expected, since volume isn't linear. So yeah, the more you know. Audio is one of those things. I want to get more into it, but it's also kind of complicated. And then we divide this by minimum decibels, but we need to keep this value between 0 and 1, and that's why we use clamp F. And next up, we calculate the height. And the height is also a float, and that is L energy times... we need to take the size of the whole box so we know how far we can go. But if we were to just do this, it will not be high enough. So I do it times 10, and this should normally be enough. Next up, we need to decide the maximum height of how high this bar can go. So we basically take our L height, we go into our max heights, and we need to get bar, well, the bar that we're working on, so bar I. If L height is higher, then we replace it. Maximum height is L height. And we need to also probably do this. L's max height is basically a LARP between max height, like the current number, and the current height. So what this basically does is LARP is making certain that it does not, like, it interpolates. It goes smoother because this kind of like, yeah, it goes smoother. Just remember that. As the bars will be going way too quickly, now they will go more smoothly. That's basically it. And then decide the minimum height. So if L height is smaller or equal to 0, then we need to change the minimum height. And we use the same LARP function to, this will be minimum height. We will basically use another LARP to like nicely interpolate between those two to have a smoother outcome. So height, the bar that we're on, we LARP between minimum height, maximum height, and we do it 0.1. And I just added 4 to make it a little bit higher. Like this 4, I'll show you later what this 4 is for. It's basically, if there's no audio, it will be completely invisible. Adding 4 makes it stick out a little bit, so it's actually visible that there's an audio spectrum there. So yeah, don't worry too much about that in 4. Next up, in the same process function, we need to queue redraw, because we will use the Godot draw function. Now, every time when we do the queue redraw, this will be updated. Something else will be printed, like this function will be called. And again, we need for every bar, so var int inside of bar counts. If I were to just do this, print I, you will see this will be updating the whole time with the bar amounts, because process function goes over this. And yeah, we don't really use delta, so let's quickly do this to get rid of that warning. So this should be empty now. But yeah, basically, we need to calculate the size of each bar and draw it. So we can do this with draw a rectangle. Inside of this rectangle, we need a color. Like, what color do we want it to be? And we also need the rectangle itself, which is a vector 4, I think. No, wait. I think there's not a vector 4. A rect 2. So a rect2, so if we go inside of Godot and we type in rect2, we can see a little bit of information. So the constructors of how you can create something like this. So we can create it from another rect, from rect2i, if you just pass a position and a size, or we can do x, y with height. Let's take the long ones just to make it more obvious of what's happening. So we need our position x, our position y, we need our width, and we need our height. So first of all, this is 0 to begin with. So if you do anything times 0, it will always be at the 0 line, so for the width. So for the here, we can just take I times bar width. So if this is 0, this will be over here. If this is 1, it will take the bar width and go over here. Now position Y, we need this to be on the bottom. And the problem is we will need to take in mind the height of the thing itself, of the bar itself, because else it will start displaying on the bottom. Because, yeah, it's just like when I started moving it without doing the mouse offset, my mouse is in the top corner. That's the same position of where the draw rect will be created. So we need to do heights. And we should probably do size y minus height I, because size y will be bigger. And this, expected expression as, is it because I have not filled in this? Okay, yeah. So this should give the correct position of where it needs to appear. And now let's just do this, so it's a little bit nicer. For the width, we take the bar width, but we want a little bit of spacing in between. So over here, you can also see there's a little bit of spacing in between, makes it look nicer. So we will just do minus, let's say 2. And now for the height, we already calculated the height, so not really much to do there. We just do heights, and we take the current, like, number of the bar. So in our draw rects, now we can add our L rect and L color. We still have not made the color, so let's quickly do that. This is the same way that the whole Godot demo project does the whole coloring. Basically, yeah, we take the bar count and we take the number to create a different color. And if you play this now, normally this should work. So if you record, now this will become clearer. And if you stop recording, this becomes less dim. These bars don't move too much depending on your microphone and your volume set. Yeah, having an option to like make this a little bit higher is probably better. But yeah, if I put this very low, you can probably see it does work. It does work. But yeah, let's put this on 0. This is just a very minimal project, and programming is basically done. Let's quickly check. So we have this, draw the rect. Yeah, I don't think there's much more for us to do programming wise. Like, yes, again, we can create the whole like settings menu and such, but it's just a minimum viable project. It works. So yeah, that's basically chapter 3 of this audio recorder series done. We have our programming, it works. Next episodes will be a little bit more, well, shorter probably, or maybe a little bit longer, depending on how long it will take to compile Godot. Because, yeah, we need to create our own export template in the next episode. Anyway, thanks for watching. A big thank you to all my Ko-fi supporters for supporting me. If you want to support me, Gozen, the videos that I do, please go over to my Ko-fi page. All donations are very greatly appreciated. Thank you very much, and I'll see you all in the next one. Bye bye.